So now we are going to look at the test for divisibility for various numbers. And let me clarify what we have done in the previous classes. We have learned about divisibility by 2, 3, 5, 9, and 10. In this section, we will learn how these tests work for 2 and 3 digit numbers expressed in a general form. And furthermore, we will learn about the divisibility test for 4, 8, 6, 11, and 7. So let's get started. So our first recap is divisibility by 10. So we need to understand for a number to be divisible by 10, it will be only divisible if it has something like 0 in its units place. So let's look at some examples first. So say 530. Is it divisible by 10? Let's find out. So let's put 530 here, 10. Then we say 5, 50, 3 here, 30. And yes, it is divisible by 10. So we need to understand for any number with 0 at its unit place, the number would be divisible by 10. So let me iterate again. A number will only be divisible by 10 if in its last or units place we have a digit of 0. So let's look at it in a generalized form. So we know we can represent a 2-digit number as AB, which is also known as 10A plus B. So in this, we need to understand that this unit digit needs to be divisible by 10 or be equal to 0. Note that both of these statements mean the same. So let's try and find out by expanding this and how it works. So since 10A is 10 into A, this is a multiple of 10, right? Then we have B, which we don't know whether if it is a multiple of 10 or if it is divisible by 10. So it can't be 1, 2, 3, 4, and so on till 9. But it will only be divisible if B is equal to 0. So to reiterate, if a 2-digit number 10A plus B needs to be divisible by 10, it will only be possible if B is equal to 0. Let's move on to another one. So for a 3-digit number ABC, that is 100A plus 10B plus C, how do we know that in its general form it is divisible by 10? So let me just clarify what happens here. We'll open up this expression. So we know 100A is equal to 10 into 10A is equal to 10 into 10 into A, which is a multiple of 10. 10A is equal to again 10 into A, which is also a multiple of 10. Here C can't be 1, 2, 3, and so on till 9. So in order to be divisible by whole number A, B, C to be divisible by 10, C can only be equal to 0. So hence, if a 3-digit number 100A plus 10B plus C is divisible by 10 only if C is equal to 0. So let's look at another example which we have done previously to learn what is a divisibility by 5. So let's take the example of 330. How do we know whether it is divisible by 5? Actually, we will take another number, 675, and see whether these both numbers are divisible by 5 or not. So let's first try. So this is divisible by 5. Let's look at 675. This is again divisible by 5. So through these examples, we know that any number that has 0 in its units digit or 5 in its units digit would be divisible by 5. This gives us a very clear generalization, which is a number is divisible by 5 if its last or units digit is 0 or 5. Let's write this in a generalized form for 2-digit and 3-digit numbers. So let's take a 2-digit number AB. It can be also written as 10A plus B. Let's take this expression and see what happens. So 10A can also be written as 5 into 2 into A, as 5 is one of it's a part of its factorization. So therefore we can say 10A is a multiple of 5. But what about B? It can't be a multiple of 5 if it is number 1, 2, 3, 4, 6, 7, 8, or 9. It can only be 0 and 5, which will be counted as multiple of 5 for in the sense of the whole number. So hence, we can again say that if there is a 2-digit number 10A plus B, it will be only divisible by 5 if B is equal to 0 or 4. Let's look at the generalized form of a 3-digit number, ABC. And this can be also written as 100a plus 10b plus c. So let's look at 100a. It can be written as 5 into 20 into a. So as we have 5 in its factorization, it is a multiple of 5. 10a, 10b similarly is 5 into 2 into a into b, which is again a multiple of 5. For c to be a multiple of 5, it can't be 1, 2, 3, 4, 6, 7, 8, and 9. It can only be equal to 0 or 5. So hence a three-digit number can be generalized as, which can be generalized as 100a plus 10b plus c will only be divisible by 5 if the last digit c is going to be either 0 or 5. Now let's recap divisibility by 2. So we know in order to have a divisibility by 2, we need to have even number at the unit place. So that means anything from 2, 4, 6, 8 and 0. Right. So in examples such as 230, 852, 2584, 331, which one would be divisible by 2? So 230 would be divisible if as 0 is at its units place. 2 is divisible as 2 is in its units place. 4, this 2854 will be divisible as 4 is in its units place. 331 will not be divisible as in its units place we have 1. So this gives us the formal rule for divisibility by 2, and that is a number will only be divisible by 2 if its last or units digit is 0, 2, 4, 6 or 8. So let's write this in a generalized form for first a 2-digit number and then for a 3-digit number. So here we take a 2-digit number as AB that can be written as 10A plus B. Let's evaluate this expression where we will have 10A and it can be written as 2 into 5 into A. As we have 2 in its factorization, it is therefore a multiple of 2. Let's look at B. B can't be the numbers 1, 3, 5, 7 or 9 if it needs to be multiple of 2. And therefore, it can only be 0, 2, 4, 6 and 8. So the generalized version is if a 2-digit number 10A plus B is divisible by 2, it will only happen if B is equal to 0, 2, 4, 6 or 8. Let's look at a 3-digit number ABC. It can also be written as 100A plus 10B plus C. And let's now evaluate this. So 100A can be written as 2 into 50 into A. As 2 is in the prime factorization, 2 is in the factorization of this number, then it is a multiple of 2. Similarly, for 10B, we have 2 into 5 into A, which is again a multiple of 2. And let's look at C. Similarly, as we did in the previous section, C would not be a multiple of 2 if in its place it would be either 1, 3, 5, 7 or 9. It can only be when C is equal to 0, 2, 4, 6 and 8. So for the 3-digit number 100A plus 10B plus C, it will be only divisible by 2 if C is equal to 0, 2, 4, 6 or 8. Let's again look at and revisit divisibility by 3. So we know that for divisibility by 3, it can only happen if the sum of the digits is equal to 3. Let's take an example of 472056. Let's check whether it is divisible by 3 or not. So we have 4 plus 7 plus 2 plus 0 plus 5 plus 6, which comes out to be 24. And 24 is divisible by 3. And therefore, this entire number 472056 is divisible by 3. Let's look at another example. We'll add the digits here and we get the number 28. And it is not divisible by 3. Therefore, this entire number is not divisible by 3. So, in its formal form, a number is divisible by 3 if the sum of its numbers or sum of its digits is divisible by 3. Let's try this in a generalized form. This generalized form might be a bit trickier from the ones we have done before. So let's take a 2-digit number AB, which can be also written as 10A plus B. For this, let's evaluate 10A plus B can also be written as 9A plus A plus B. 9A plus A plus B now should be divisible. How should we make this possible that it is divisible? So we know that 9A is 3 into 3 into A. So as we have 3 as a factor, this is multiple. This version is multiple of 3. For a plus b to be a multiple of 3, we need a plus b to be divisible by 3. So, in the generalized form, a two-digit number, 10a plus b, would be divisible by 3 if the sum of digits a plus b is divisible by 3. Now, for a three-digit number, abc, let's evaluate this expression. So, 100a plus 10b plus c can also be written as 99a plus a plus 9b plus b plus c. We have just expanded 100a and 10b. So we know 99 is 3 into 33 into a. As 3 is a factor, we can say this number is a multiple of 3. Similarly, for 9b, we have 3 into 3 into b. As we have a multiple, as we have a factor of 3, this is again a multiple of 3. And we are left with A, B, and C. So A, B, and C, for making it the whole number to be divisible by 3, the sum of these three digits should be a multiple of 3. So hence, for a three-digit number, we can say it is divisible by 3 if the sum of these three digits is divisible by 3. Let's finally recap the divisibility by 9. It says that if a number needs to be divisible by 9, the sum of its digits should be divisible by 9. It is very similar to the divisibility test of 3. So let's get started. Let's check whether this is divisible by 9. The sum of the digits is, and this comes out to be 27, which is again divisible by 9, and therefore this whole number is divisible by 9. Let's similarly take another number and check for its divisibility by 9. We'll take the sum. This comes out to be 31. And we know that 31 is not divisible by 9. And therefore, this whole number is not divisible by 9. And if we have to write this in a general form, for two-digit number AB, we have 10A plus B. Let's write it again as 9A plus A plus B. So 9A is divisible by 9. So we need to make sure that A plus B is divisible by 9. It should be a multiple of 9. So hence, a two-digit number 10a plus b is divisible by 9 if the sum of its digit is divisible by 9. For a general form, for a three-digit number abc, we have 100a plus 10b plus c. We can write this down easily as 99a plus 9b plus a plus b plus c. 99 is a multiple of 9. 9b is a multiple of 9. Then we need to create a plus b as a multiple of 9 too, for the whole number a plus abc to be a multiple of 9. So hence, for a three-digit number 100a plus 10b plus c, it will be only divisible by 9 if the sum of its digits a, b, and c is equal to or is divisible by 9. Let's move on to divisibility by 4, which is the new one. It says that a number is divisible by 4 if the number formed by the last two digits of the number is divisible by 4. Let's take a big number, 47052, and see whether it is divisible by 4 or not. So we need to look at these last two numbers. We don't need to think about any other number and see whether this is divisible by 4 or not. Let's take a quick look, and it turns out to be that these two last numbers are divisible by 4, and therefore this entire number is divisible by 4. So divisibility by 8 is very similar to divisibility by 4, but in this one we need to look at the last three digits. So let's take an example. We have 97056. So in this we need to take the last three digits and see whether this is divisible by 8. We don't really need to think about any digits before than that. So let's see if 056 is divisible by 8. So we know 56 is 7 times of 8. So 56 by 30. So this is divisible by 8. So the entire number is divisible by 8. Another new divisibility that we are going to look at is the divisibility by 6. The number needs to be divisible by both 2 and 3 in order to be qualified to be divisible by 6. Why does this happen? Because if we factorize 6, we get 2 and 3, and 6 is the product of these two numbers. Therefore, we need to divide our divisibility into these two and 3 values, which we have already covered previously. So let's look at an example. So we have 53022, and we have to check whether this is divisible by 6 or not. So first, we have to do this in two parts. First is divisibility by 2. So we have to check whether the units place is either 0, 2, 4, 6, 8. And in this number, we have 2 in its units place. So the divisibility check by 2 works. So in the divisibility check by 3, we need to add all these numbers and check whether that is divisible by 3 or not. And the sum comes out to be 12, and therefore this is divisible by 3 as well. So as we have completed the checks for both divisibility by 2 and by 3, we can say that the number is divisible by 6. So let's quickly look at the divisibility by 11. This is a very crucial one where you'll need to think about what kinds of numbers you're adding, subtracting, and what you're trying to find. So we have two methods. The first one, let's look at that. So a number, if it needs to be divisible by 11, it should function such that the difference of the sum of the digits at the odd places and the sum of the digits at the even places is either 0 or it is divisible by 11. Let's consider an example and try to find this out. So our example is 5869217. Let's take out digits at the odd places. So digits at the odd places are marked by the red dot. So that is 7 plus 2 plus 6 plus 5. That comes out to be 20. And the non-dotted places are 1 plus 9 plus 8. And this comes out to be 18. So the difference is 20 minus 18, and that is 2. And this number is not divisible by 11. Let's take another example. Let's mark the odd places in red dots and take the sum of these odd places. This comes out to be 3. And at even places without the dot, and this comes out to be 25. Let's take the difference, and that comes out to be 25 minus 3, which is 22. And this is divisible by 11. Therefore, the entire number is divisible by 11. Let's look at the second method. The second method states that a number would be divisible by 11 if the sum of digits in blocks of 2 digits from right to left is divisible by 11. So let's take an example for this. Let's take a number and let's create the blocks of digits from right to left. So this is the direction that we need to work on. From right to left, we have 82 as the first block, 80 as second, and 91 as the third block. When we take the sum of it, it is 253. And we need to find if 253 is divisible by 11. And as it turns out, it is. So therefore, this entire number is divisible by 11. Divisibility of 7 states a number is only divisible by 7 if the difference of the sum of the digits in alternating blocks of 3 digits from right to left is divisible by 7. So we need to note that this is very similar to the second method that we just saw for the divisibility test of 11. So let's understand this by a very quick example. Let's take a very big number. So we need to create blocks of 3 digits from right to left. So I'll just mark the alternating blocks. First is 272, then we leave out 911, and then we have 532, and then we have 47 in the next block. So because we need to take the difference of these two blocks, I have marked them differently. So let's take the sum of block 1, and this comes out to be 804. For the next block, the sum of this comes out to be 958. Let's find out the difference, which comes out to be 958 minus 804, and that is 154. Now we need to find whether this 154 is divisible by 7 or not. And as it turns out, it is. So therefore, this entire number is divisible by 7. So this brings us to the end of our divisibility test. And now let's look at some examples which might come during our exams. And I hope you remember all these divisibility tests so that we can apply those in the coming examples. So in this number 3791 asterisk 5, we need to find a digit asterisk which makes this entire number divisible by 9. So how do we approach this kind of a question? So let's first remind us what is the divisibility of 9. So in order to understand that, we know that divisibility of 9 comes out when the sum of each digit in the number is divisible by 9. So let's first take the sum of the numbers we know, and this comes out to be 25 plus asterisk So we need to understand that 25 is not divisible by 9. So what should we add to a number? This should be a non-zero number because we already know that 25 is not divisible by 9. So the first number that comes to our mind when we think about multiples of 9 is, if we think about the table, we have 9, 18, 27, 36, 45, and so on. So this exact number asterisk can be, the entire number can be either 27, 36, it can't be 18, 9 because that would be smaller than 25. So it should be greater than 25. This can be 27, 36, 45, and so on. So in order to make this number divisible, we need to either add 2 to it to get it to 27, or 11 to it to make it 36, or 20 to it to make it 45. So these can be some of the examples, but as we know that asterisk is just one digit number, we can't choose every one of them, and therefore 2 is our only choice. So we need to add 25 plus asterisk, that is equal to 2, to make it 27, which becomes divisible by 9. Let's look at another example. So in this example, we have this number 47x562, which is divisible by 3. So we need to find a particular value of x so that this whole number remains divisible by 3. So it is very similar to the previous example, but here we have divisibility by 3. So what do we remember about the divisibility test of 3? So the sum of all these digits should be a number which is a multiple or is equal to 3, or in a better sense to say, divisible by 3. So let's take the sum of all the digits of this entire number, and this comes out to be 24 plus x. So we already have 24, which is divisible by 3. So what are the possible values of 24 plus x that can fulfill divisibility test? So this can again be 24, where x is equal to 0, 27, where x is equal to 3, 30, where x is equal to 6, 33, where x is equal to 9, and so on. 33, and we'll just write a few more. So x can be anything from 0, 3, 6, 9, 12, 15, and so on. But as x is a single digit, we can only take from the single digit value. Therefore, x is equal to either 0, 3, 6, or 9. Let's take a look at another example. So in this question, we need to understand the divisibility of 11 for this number, where there's a digit named x. And we need to find the value of this digit so that this divisibility remains intact. So let's think about what is the divisibility test for 11. So for that, the difference of the sum of digits at the odd places and the sum of digits at the even places is either 0 or divisible by 11. So let's write this number out. So I'll mark the odd places with a dot, and let's take the sum of the odd places, and this comes out to be 10. Let's take the sum of the digits in the even places, and this comes out to be 17 plus x. So the difference of 17 plus x minus 10 should be either 0 divisible by 11. Let's simplify this. This becomes 7 plus x, which can either be 0 by 11. So in order to make 7 plus x equal to 0, that can't happen because there's no positive digit that can make that happen. So this does not work. So we look at the divisible by 11 part. So 7 plus x needs to be divisible by 11. What number should I add to 7 that it becomes divisible by 11? So let's take a look at the table of 11. There's 11, 22, 33, and so on. So the first number that we have is 11. So in order to find that out, we can say 7 plus x equal to 11, and x comes out to be 4. We can also try this for another number. So say 7 plus x is equal to 22, and x comes out to be 22 minus 7, which is 15. So as x needs to be a single digit number, this is the only value that satisfies our equation, and this not, because this is a two-digit number. Therefore, the value of x is 4. I hope you liked my video on divisibility tests and playing with numbers with different puzzles. Please don't forget to like, share, and subscribe to my channel. Thank you.